Okay, so thank you for the introduction. As I was introduced, I'm Lukas Harzenetter, and together with my colleagues Uwe and Kalman, we did a paper about freezing and defrosting cloud applications, and so how we can save the state from a distributed system and restore it afterwards. I'm just giving a short introduction into deployment technologies, but we already heard this yesterday from Michael Oster. Deployment of application is, as we all know, error-prone, time-consuming, and so we have to automate it, and therefore there are this bunch of, for example, these applications, and there we have a declarative deployment models where we model what should be deployed, so the actual components and their relations, and then we have an imperative model which describes how the deployment should perform. So just to get you an impression on how a declarative deployment model works, because we were building or starting on a declarative deployment model, and this is such a declarative deployment model. So in this example, we have a basic PHP application as a web front end. Then we have a processor component which is running an OpenStack environment, and it, for example, saves some data in a database. And so we have this database which is stateful, and just for explaining concepts, we are going to assume that we have a also stateful Java application, so for example, holding session states, and we have this stateless web component here. So the problem now is when I terminate this application, or if I want to free the resource because I don't need the application anymore, we lose the state. And in this example, the database state is more precious than the Java processor state, but let's assume you. So both states are basically lost. So, and yeah, the thing is, if we have a business application, which is, for example, only used during daytime, so between 6 and 8 p.m., and then it's crucial to get this data out of the system and put it back in again when we restart the application. So, for example, we can also do this in a more longer time span, for example, for 2 years, as most of you will know, the 1 month, for example, which is only running during specific times, for example, before there are elections in Germany. So when we terminate the application, we lose the state, but we want to terminate the application to save resources and consequently money, and so we were focusing on how can we get the state before we terminate the application, and then how can we put the application back in the system while we start it. Therefore, we introduced the freeze and defrost approach. It basically starts with modeling a declarative deployment model. Okay, so this has to be done manually since this is a critical task, and then we are generating imperative plans. So we are deriving from the declarative deployment model the steps they have to be executed, and then we package it into a imperative deployment model, and we have different plans. So the deployment plan, for example, the freeze plan, and the defrost plan. And this together is a deployment package, and this is This is then deployed by executing the deployment plan, and then we get a running instance. And now, if we want to terminate the application, we execute a freeze plan, the running instance is removed, so we save the resources and the money. And then we are creating a stateful deployment package, which also contains the data from the database, in this case. And now we are executing a defrost plan, getting this running instance back, or another running instance, which has this data which we saved here and then. And as you can see, this here is a cycle, so we can repeat it multiple times. And we always have a new deployment package with new data. So, and this is completely automated, so we have the runtime and management phase here. So, but how is it going to work? So the approach in more detail. So as I just said, we are creating manually a deployment model. Then we have to find the stateful components in the deployment model, and we are annotating them, and we are using a type deployment model. So we are assuming that the type has already a stateful annotation, so that we can define or derive that these instances of the types are also stateful. And then afterwards, we are searching for freeze and defrost operations, and then we are annotating them with this snowflake here. And for example, this here was our database, which is feasible because we can, for example, do a SQL dump and save just the SQL file. But for the Java application, we don't have operations to get the data out. So we are going the stack down and are searching for other components which can be freezable. So which have these freeze and defrost operations. And in this case, we have a virtual machine, for example, which implements these these operations, and then we are annotating this component here. So because we are freezing the whole VM, which is hosting the processor and the database, we say, okay, this annotation here is unnecessary, so we are trying to reduce the amount of data we need to store. And then we have a clean deployment model step where we remove all the unnecessary snowflakes, and then we are generating our freeze and defrost plans. So according to these annotations, we can then derive the order of execution and how we also so to freeze the application and to defrost it again. So this was basically the overview of our approach. Thank you for your attention, and I'm happy to answer your questions at the poster session.
Thank you. Now we really have time for at least one question, because he's 1 minute ahead of time. But you can come up with it. Yeah.
Do you use the OpenStack instances snapshots to create the frosted state machines?
Yeah, you can do that. Yeah. So we have it more generically. So these freeze and defrost operations are generic. So how it's implemented will depend on the infrastructure you use or the components you use. But yeah, if you have an OpenStack infrastructure, you would use the API.
So you can defrost multiple times?
Yes.